So this video is on negative and fractional indices. It's a follow-on from my index laws video. It's more to do with year 10 top level stuff, so year 10 and 10A curriculum. So basically negative indices are when we've got something like this, where we have a number or a letter to a negative power, so that's a negative indice. And then we have fractional indices where we might have 16 to the power of a half, and that actually means the square root of 16. And we'll go over that a bit later. I'll focus on negative indices first. So our general rule for negative indices is if we've got something to the power of a negative number, we end up putting it to the bottom to make it a positive. So basically we do the reciprocal of it. So what that means is if it's a negative power at the top, to make it positive, we have to bring it to the bottom of a fraction. And then the second part is if it's a negative power on the bottom of a fraction, to make it positive, it goes to the top. So that's our general rule for it. And if you can just remember that if there is a negative power on the bottom, it goes to the top. If there's a negative power on the top, it goes to the bottom, then you should be okay. So our first example is 2 to the power of negative 4. So basically, the first step that we do is we move our power to the bottom. So it would become 1 over 2 to the power of 4. It's a 1 because obviously if it's, at the moment, this is actually 2 to the negative 4 over 1. Okay? So when we move something to the bottom, it can't be 0 because it's actually, that would make the whole fraction 0. So it has to be 1. And then we have 1 over 16 because 2 to the power of 4 is 16. Our second example has the negative power on the bottom. So what that means is when we bring it up to the top, it's going to become 1 times 3 squared. Now, realistically speaking, we don't need to put the 1 there because it doesn't change it. But sometimes it might not be a 1 and you need to understand that it is that multiplied by that. So we would end up with 9 for that answer. So our second example is one that involves letters now. So basically for the first one, you'll see that there's a negative power on the top and on the bottom. So the first thing you do is move the powers. Okay, so we would leave the a cubed where it is because that's not negative. It doesn't need to go anywhere. But the b to the power of 4 needs to go to the bottom. The b to the power of 6 is going to stay on the bottom. And then the a to the power of negative 2 is going to come to the top to make it positive. And remember I said in the last example, these are little time signs between them. So when we get to here, we just use our index law 1, where we add the powers. So we'd have a to the power of 5 over b to the power of 10 as our final answer there. Example 2, part B, we've got something raised to a power that's raised to a power again. So what we do is we have to remember there is that little 1 next to the 3. So it becomes 3 to the power of negative 3 because we multiply the indices, and a to the power of negative 6. So both of these powers are negative, which means we have to move them to the bottom. So we'd have 1 over 3 to the power of 3, a to the power of 6, and then we can expand the 3 to the power of 3, which becomes 27. So we've got 27a to the power of 6 as our final answer there. Our next example is a little bit bigger. So it's one where we've got a fraction multiplied by another fraction. So what I do first is I tend to move the negative powers before I do anything, because that way I'm not working with negatives anymore. I just move the negatives. And what I'm going to do is, because if you look at our last example, part A here, notice how when I moved the a to the negative 2 up to the top, I added it because we were doing multiplication, which means we add the powers. So when I do this question, when I move the x to the power of negative 2 to the bottom, I'm just going to add it straight away. So I'm going to have x to the power of 5 on the bottom because that negative 2 is going to come to the bottom. And the same with the y to the power of negative 4, that's going to go to the bottom and become addition to that as well. So it's 9, and we're left with 1 on the top. Then we do the same to the other side. So the x to the power of 4 is going to stay where it is. And then the y to the power of -5 has to go to the top, and the y to the power of -3 has to come to the bottom. And notice I've made them both positive because I've shifted them from bottom to top and then top to bottom. Now I multiply the fractions. So I go across the top, I multiply across the top, and we just get x to the power of 4, y to the power of 5, over x to the power of 5, y to the power of 12. And then I simplify again. There's more x's at the bottom, and there's one more, so we're going to have x at the bottom, and then there's more y's at the bottom as well. So we've got 7 y's at the bottom. Just rewrite that a little bit better for you. Put it over here. So it's 1 over x y to the power of 7. Okay? Next one. Same again, it's a division, but before we even start the question, we're going to move our negatives. So the first fraction is just going to stay as it is. There's no negatives in there, so we don't need to do anything. We'll leave the division sign. I'm going to move the x to the power of -3 to the bottom to get x to the power of 6. And I'm going to move the -2 to the top to get y to the power of 6. Now, using normal division of fraction rules, I swap the second fraction. So I'll leave this first one as we are. I will swap the second fraction to x to the power of 6 over y to the power of 6, and I'll change the sign in the middle to a multiply. Then again, I just multiply across the top, so I get x to the power of 10, y squared, over x cubed, y to the 10, and then we just simplify it as per our normal rules. So there's more x's at the top, so they stay at the top, and there's more y's at the bottom, so they stay at the bottom. And then that's our negative powers finished. Now we'll move on to fractional indices. So our general rule for fractional indices is if we've got something like a to the power of 1 over n, that actually means the same as the nth root of a. So, like we did our first example, we did 16 to the power of half. That was the same as saying the square root of 16. If we have something like a to the power of 1/3, it means it's the cubed root of a. Or a to the power of 1/4 is the fourth root of a. And what it means by the third or the fourth root is some number multiplied by itself 3 times is the cubed root, and some number multiplied by itself 4 times is the fourth root, etc. So, our first example is 49 to the power of half. Now, because it says to the power of half, we are doing this, so it's the second root, but the second root is just a square root, so we actually don't need to write the little 2 there. So it's the square root of 49. So in our heads, we're thinking what multiplied by itself gives us 49. And we know, or you should know, that it is 7. 7 times 7 is 49. Our second example is a cubed root question. So this time we're doing the cubed root of 64. So something multiplied by itself 3 times gives us 64. Now if you're unsure, start with 2. And you do 2 times 2 times 2, that's 8. Okay, so it's got to be more than that. You should know that 5 times 5 times 5 is 125. So it's got to be less than that. So we end up working out that it is 4, because 4 4s are 16, and then 16 4s are 64. It does help if you know your bases to the power of 1 to, say, 5. It does help to know that, and it does help for when you're trying to solve exponential equations later on as well. So then we've got our second example is just to do with letters, and this is just to show you that the fractional powers do work the same as normal index laws. So if we've got b to the power of a half times b to the power of a half, that means that is going to be b to the power of a half plus a half. And then we're also multiplying by a to the power of a half here. So what we would end up with is b to the power of 1 and a to the power of a half. But we try to avoid writing fractional indices when we can. So we would end up with the square root of A times B. I've only changed it to the square root of A times B because we write in alphabetical order when we can. Our next one is a little bit more challenging, so we have to remember that all the index laws apply, so we have to treat this 8 as to the power of 1. So we would expand this first, so we'd have 8 to the power of 1/3, A to the power of 3 times 1/3. So I will write that. You don't have to write this when you're doing your working. And then B to the power of 6 times 1/3. So A to the power of a third means the cubed root of 8. Then we'd have A to the power of 3 times 1/3. Well, 3 lots of 1/3 is just 1. And B to the power of 6 times 1/3, 6 lots of 1/3 is 2. So we would put B to the power of 2. Then we can actually work out the cubed root of 8. So 2 times 2 times 2 gives us 8. So we would have 2AB squared as our answer there. The next example is a little bit harder. So we have to make sure we treat the 32 with the power again. And the same as before, we just make sure we multiply that power the whole way through the bracket. So we would have 32 to the power of negative 1/5, A to the power of 3, because we would end up with 15 over 5, which gives us 3, and then B to the power of negative 1, because it would be 5 over 5, negative 5 over 5, so it would be negative 1. Then we move what we need to move to the bottom, so we leave the A cubed where it is, and we would end up with the 5th root of 32 and B on the bottom. Now, the 5th root of 32, to multiply something by itself 5 times and only get 32, it has to be quite a small number. So hopefully you've worked out that it would be 2, so we would end up with A cubed over 2B as our answer to that question. The last two examples for this video are ones where they're not just 1 over something, it's like 3/4 or 5 over 2 or something like that, and I'll show you how to break it up. So for the first one, we need to split this fraction up, and we do that by working out how we actually got 3/4. So 3/4 is 1/4 times 3. So what we have is, if we put it like this, 16 to the power of 1/4, all to the power of 3, that's how we get 3 times 1/4. So I've split it up. Now I can work out that the 4th root, so we're doing the 4th root of 16, all to the power of 3. So the 4th root of 16 is 2, so we would have 2 cubed, and that equals 8 as our final answer. And this one here, we've got 9 to the power of 5 over 2. Now that is 1/2 multiplied by 5. So we would have 9 to the power of a half, all to the power of 5. So 9 to the power of a half is just the square root of 9. So we're doing 9 to the power of half, or the square root of 9 to the power of 5. The square root of 9 is 3, so then we end up with 3 to the power of 5, and 3 to the power of 5 gives us 243 as our answer. These sorts of questions do require quite a bit of practice. Anything to do with negative powers and fractional indices do require practice. So hopefully this video has helped you with those, and you can rewatch it as many times as you need to.